Hi folks, now we're going to talk about highlights from week 2 from Advanced Statistics 6022, and we're going to talk about data cleaning, data screening, and data meeting statistical assumptions. So what is data cleaning? Data cleaning is really all about getting to know your data. We do that several different ways. One way we do it is by running frequencies. We're checking the minimum, the maximum for our quantitative and qualitative variables. For our continuous or quantitative variables, we're also looking at the mean, the median, and the mode. We're looking at whether they're normally distributed. We're also looking at what does the general pattern of values tell us about what was measured. For example, if depression was measured, was it generally high or low in your sample? We're also looking at how much data was missing. What percentage of each variable had missing data? Was it 1 or 2%? Was it 5%? Was it 25%? We're also looking at how large our sample was that had complete data. And we're also looking at how large any subgroups of our data are. Were they, for example, at least 30 to 50 or more cases in each subgroup? For example, if an important aspect of our data is age groups, let's say 18 to 39 and 40 to 59, was there at least 50 in each of those groups? How even were those groups? Was there at least a 90%, 10% split so that no group was smaller than 10%? So in data cleaning, we're looking at all of these things. In terms of data screening, first we're looking at the pattern of missing data. If you have the missing values analysis module in SPSS, there's a lot of really nice ways to do that. One thing we want to know about missing data, is it missing completely at random? Is it, which is MCAR? Or is it just missing at random? Is it not missing at random? And in our cheat sheets and in chapter 3A and 3B, those terms are discussed a little bit further. As a general rule, if missing data is 5% or less per variable, typically we can use simple replacement techniques or possibly listwise deletion. Listwise deletion is when we eliminate any case, which is a row of data, with one or more missing values on your IV or your DV that you're going to include in your analysis. More on data screening, we also check for univariate outliers, which just means are there any scores in each of your individual variables. Univariate means one variable at a time. Is there a very high score or a very low score that's far enough away from your other data that we call it an outlier? And we look at frequencies, stem and leaf plots, and box plots to find those. We also analyze for multivariate outliers. Multivariate outliers look at all of the independent variables together on the dependent variable, and we can compute something called Mahalanobis distance statistic to identify those multivariate outliers, and the material in chapter 3B takes us through how to do that. It's pretty straightforward. We also examine descriptive statistics, again, to continue to get to know our data. So we're looking at skewness, kurtosis, histograms of our quantitative variables, bar graphs for our categorical variables. So all of these different techniques are data screening. And then finally, the third thing we're doing is asking whether our data meets the multivariate statistical assumptions. Here are some of the common ones across statistical analyses, and then there might be additional ones for particular statistical analyses. So the most common ones are the ones you see here: normality, linearity, homoscedasticity, independence of errors, and whether data transformation is required for any of these variables. So normality, we're looking at it one variable at a time, which is called univariate normality. We're looking at multivariate normality, which is considering all of the IVs together on the DV. And we're also, for some analyses, we're looking at normality of residuals. That's also very important. With linearity, we want to know whether a quantitative independent variable is linearly related to the quantitative dependent variable, and to some extent whether two quantitative independent variables have a linear relationship, or whether two quantitative dependent variables have a linear relationship as opposed to a curvilinear relationship or no relationship. With homoscedasticity, we're looking at whether the quantitative dependent variable has equal variance, which again is just differences from the mean for each person in the data set, for their scores in the data set. Does each value in the dependent variable have equal variance across all levels or values of the independent variables? And we have tests that check for that. For independence of errors, basically we're looking at, does one person's dependent variable score, is it not more or less related to another person's dependent variable score, as might occur, for example, in classroom level data? So is everybody's score not related any more or less to everyone else's score due to how the data was collected? And finally, based on what we learn with these assumptions, do we need to transform any variables because they're not sufficiently normally distributed? So the chapter goes through how to check all of these. So we have lots of ways to check on statistical assumptions. For most of them, there's some type of graphical technique. So we look at the data, there's a visual graph that we can look at. There might be statistical tests that we can use. See Chapter 3B annotated output, and also the Chapter 3 cheat sheet to see how to do these, which techniques to use for which assumption. Also review Chapter 3A for a more in-depth explanation. Again, focus on what you do understand, skip what you don't. Sometimes the authors go into a lot of detail on things that might be a little less important. So again, focus on what you understand. You're going to understand more and more of it as you work with it more. And we'll also see additional assumptions with certain specific analyses throughout the semester that will be in those particular chapters. And then also in your data analysis assignment, you're going to be using these techniques to check your data. So for your learning, try to do this 2 or 3 times this semester, even if it's one time, but try for 2 or 3 times. Reread Chapter 3 as we progress, particularly Chapter 3A, as we progress throughout the semester. It's going to make more and more sense to you as you see these techniques repeated with each of the statistical analyses we're going to go through. Also review the cheat sheet for Chapter 3 and also the Chapter 3B annotated output. Again, it's going to make more and more sense to you because we're going to repeat looking at statistical assumptions for many of the analyses we'll do each week. And then also reread Chapters 2 and 3 of the Elliott and Woodward text from last semester that you're also using this semester. And again, you will be surprised how much you remember and how you begin to understand it. So once again, thank you so much for your attention, and don't hesitate to email me with any questions.